Hello everyone. In the previous video, we studied about the JFET. It's kind of the different kinds of JFETs, that is N-channel JFET and P-channel JFET, its characteristics, working principle, and we also studied about the MOSFET, where we studied about the depletion type MOSFET and the enhancement mode MOSFET. Here we studied the characteristic of the MOSFETs also, whether it could be in terms of depletion mode or whether it could be in terms of enhancement mode. So today we are going to study about the another kind of FET, that is nothing but our CMOS, that is complementary metal oxide semiconductor. Now, for this complementary metal oxide semiconductor, this is what is the complementary metal oxide semiconductor, wherein which along with the P channel FET, it is going to have the N channel MOSFET along with the N channel MOSFET. That is, the name itself suggests a complementary. We cannot just use a single MOSFET, that is whether it could be an N channel MOSFET or whether it could be a P channel MOSFET. If I use one of them, the complementary version should be added to that. So this is what about the complementary metal oxide semiconductor field effector transistors. This was realized. This is used mainly for the digital designing of the digital systems. Reasons for its popularity are for its small size, ease of fabrication, low power operations, relatively simple in manufacturing process, high impedance will allow it to use as a charge storage device also. So all these features have contributed to the high levels of integration and correspondingly sophisticated circuit designs. So what is a CMOS? Let us have an overview of what is a CMOS and what actually it will do. The CMOS is referred as a complementary metal oxide semiconductor. It is also sometimes known as complementary symmetry metal oxide semiconductor. Complementary and symmetry refers to the complementary and symmetrical pairs of N-type and P-type MOSFETs in its design. The main disadvantage of this low static power consumption and noise immunity. Since one transistor of the pair is always off, the series combination draws a significant power only momentarily during switching between on and off states. CMOS circuits use a combination of P-channel and N-channel metal oxide field effector transistors to implement any of the logic gates. So a complementary version should be available whenever we use a CMOS technology. Now, the main application, that is one of the main application of our CMOS, is the CMOS is used as an inverter circuit. So the CMOS inverter circuit is as shown here. So this is my this acts as a this is my when I take an N channel and a P channel, when I take a P channel and a N channel, sorry, I showed it reverse. So this is your P channel and this is my N channel. So when we use it in pair, that is this is nothing but our complementary metal oxide semiconductor. So when you look into the inverter circuit, so this is our inverter circuit, wherein which the inverter circuit consists of two complementary MOSFETs, PMOS and NMOS. The input I is given to the gate source, that is the gate of the gate of the NMOS and the PMOS is shorted together and given and the input is given to the gate terminal. The NMOS transistor has an input from VSS. Yes, the NMOS transistor has an input from VSS or ground, and the PMOS transistor has an input from VDD. That is, the source terminal is going. That is the source of the NMOS transistor. The source of the NMOS transistor is given with VSS ground, and the drain of the PMOS is given with the VDD, right? So inverter is it is a logic circuit where the applied signal when the applied signal is 0 volt, if at all it is a 0 volt, the output should be 1. So the terminal O, wherever the terminal O is shown, this is going to serve as a output for both the NMOS, output from both the NMOS and PMOS MOSFETs. When a high voltage VDD is given to the input terminal I, the NMOS is turned on while the PMOS is switched off. The output is pulled down to VSS. Similarly, when a low voltage I is equal to 0, that is whenever we make our input voltage as equal to 0, the NMOS is switched off while the PMOS is switched on. The output in this case becomes VDD. The output is pulled up to VDD. So this is about the CMOS inverter, right? Now, how the operation is going to be performed. For a PMOS to operate, so this is our PMOS MOSFET. For a PMOS to operate, the VGS should be greater than equal to VTP, where VTP is the threshold voltage when a high voltage VDD is applied to the VGS terminals for the PMOS transistor becomes a 0. Since VGS does not satisfy the above condition, therefore the PMOS does not operate and it is assumed that it behaves like an open circuit. So that is what is shown here. It assumes it opens as an open circuit having high impedance. However, this VGS for NMOS is high, right? So which is higher than the VTN, satisfying the condition for its operation. So hence the NMOS is going to NMOS is going to conduct by pulling down the output to VSS. On the same line, the inverter operation can be explained for a low input voltage I. In this manner, the NOT gate is realized using CMOS inverter. Okay, so what actually is happening here is we are going to apply the high voltage, that is whether it could be VDD or VSS more than, so whatever we are high voltage is applied across the VGS terminal, whatever the PMOS is there, this is going to not conduct and my NMOS is going to conduct. So so whenever we apply the high voltage, right, so VGS is higher than, so NMOS is satisfying the condition, that is its threshold voltage is going to become higher than the VGS. As a result, the NMOS is going to conduct and this will pull down the output to VSS, right? So that is ground potential. Whenever I make my input as equal to 0, the NMOS, that is the PMOS, whatever the PMOS is there, that is going to satisfy the condition, that is nothing but VGS is greater than VTP. Hence, the PMOS is going to conduct and pulling up the transistor output to VDD. So this is how the CMOS is going to work as an inverter. So what should be, the points that we should remember in the CMOS inverter is a high voltage corresponds to logic high 1 and a low voltage corresponds to logic low 0. So high voltage means it is 1, low voltage means 0. The higher voltage is usually taken as VDD, the higher voltage is usually taken as VDD or the source voltage, and the low input is usually equal to 0 volt, which is as summarized below. So when you look into this table, 0 volt is taken as 0 input and the output whatever the across the CMOS inverter is VDD, that is logic output 1, and similarly whatever the input VDD is given, the logic input is 1 and the output at the output across the CMOS inverter is 0 volt and the logical output is, and that is logical output is 0. So whenever we study about the CMOS, the main the first application that we can see is basically the CMOS is going to work as a inverter. So this is how the CMOS is going to work as a inverter. Hope this video is beneficial for you. Thank you for watching.